In this video, I'll show you a linear static analysis of a tractor axle assembly using ANSYS AIM. AIM comes with a number of predefined templates that define simulation processes. Today I'm going to begin by selecting a structural template. The template has a number of options, and I'm simply going to accept the defaults and execute the template. The template's now successfully completed. It prompted me to select a geometry file, and the template set up a series of tasks that define my simulation process. I have a task for geometry, a task for mesh, physics, as well as results. By following the tasks, AIM will guide me through the simulation process. Let's begin by selecting the mesh task. The default mesh in AIM can be specified by setting the mesh resolution slider. The slider controls the overall density of the mesh. For my example, I'll accept the defaults and update the mesh task to generate the mesh. By default, AIM uses parallel meshing to rapidly generate a finite element model for even a complex geometry. Now that the mesh is complete, I can review the mesh density. Note that AIM automatically recognizes small features in the geometry, such as small fillets and holes, and AIM automatically refines the mesh density in the vicinity of these small features to accurately capture the geometric detail. Next, I'll move to the physics task to review the options of the physics setup. AIM automatically detects and defines bonded connections between the various parts of my assembly. To review the connections, I can just hover over each individual connection to review the contact surfaces between the various parts of my assembly. Next, I'll apply the boundary conditions. I'll select a face and apply a moment load directly to the model of 70,000 Newton meters. Then I'll select a face on the opposite side of the model and apply a fixed support to constrain the tractor axle assembly. Once the boundary conditions are applied, I can review them simply by toggling on or off the display of the individual boundary conditions. Now I'm ready to solve the model, but before I execute the solution, I want to show you that everything that I've done today is captured in an AIM journal file. AIM captures all of the interactive steps in a Python-based journal file, which I can modify, use to create a script, and use to automate my simulation. Now I'll go ahead and execute the solution. I can update the results task, and this will execute the solution and compute the displacement and the stress results for the tractor axle assembly. By default, AIM computes displacement and equivalent stress results. I can review the deformations in my assembly, and when post-processing, AIM takes advantage of both the CPU and the GPU to enable rapid results exploration. I can also review the equivalent stress results or any other result quantity that I may be interested in. All results quantities can also be animated, such as the displacement animation that's shown here. Thanks for watching this demonstration of ANSYS AIM.